Okay, children. So we will discuss some important questions in the motion lesson which I gave children morning homework. Those who did not understand, please see here first question, children, in motion lesson. So I gave an object is dropped from rest from a height of 150 meters, of course. Okay, and simultaneously another object is dropped from rest at a height of 100 meters. Another object is dropped from 100 meters. Okay. What is the difference in their heights after 2 seconds if both the objects drop with the same acceleration? How does the difference in heights vary with time? Okay, children. So question is, see here, children, try to understand. An object is dropped from rest at a height of 150, and similarly, another object is dropped from rest at a height of 100 meters. What is the difference in their heights after 2 seconds? Children, after 2 seconds. Now, initially, what is the difference? Can you see? Initially, what is the difference?
50.
50
meters.
meters.
50.
Even after 2 seconds, it will be 50 meters only. Even after 3 seconds, 50 meters. Even after 4 seconds, 50 meters. You will say, no, sir, we won't believe. Sure. If you don't believe, I will show you. If I, okay, so.
Sir, do they have the same acceleration?
Yeah, same acceleration. Acceleration due to gravity, no? So, first body, half G, normally, what is our formula children? We have S is equal to ut plus half at square. H is equal to 0t plus half gt square. Please try to understand. H is equal to half into g is how much? 10. T is 2 seconds, 2 square. This one. 20 meters, this will go. 20 meters, this will go. Okay, so 20 meters it is coming means 130 meters. 20 meters it means 80 meters. 130 minus 80 is again 50 only. That's what I'm saying. You're able to understand, children, what I'm saying? Both of them
Yes,
are
sir.
both of them are dropped. So because both of them are dropped after 1 second, after 2 seconds, after 3 seconds, after 4 seconds, their height difference remains 150 only. So the difference in the heights is 50 only even after 2 seconds. Even after
Sir, their weights can vary, right? Their weights can vary.
I didn't understand what you say.
Their weights can vary, right?
Weights, weight
Can vary.
no, that's speed. The height does not depend upon weight. No, see anywhere, anywhere is it depending upon mass? It's not depending. RG square. That's all. Any weight it be. Let it be any weight. You take 100 kg and 10 grams also it is same. Second question. Okay, because acceleration due to gravity at the place is same, so it all depends upon acceleration due to gravity. Second question. An object starting from rest means initial velocity is 0, travels 20 meters in first 20 meters in first 2 seconds, and then 160 meters in next 4 seconds. Okay, what will be the velocity after 7 seconds? After 7 seconds from start. After 7 seconds from start, what will be its velocity? You want me to do it normally or you want me to do with graph, children? Your wish. However you
Graph.
want.
Graph.
Okay. Okay.
Graph only, sir.
Graph, sir.
Your wish. However you want, children. So 0, 2 seconds, 4 seconds, 7 seconds. Okay, children, 0, 2, and 4. So, children, in 2 seconds, it traveled 20 meters. But in 4 seconds, it traveled 160 meters. 160 meters. Okay, you can't draw graph for ST graph, children. I'm sorry. You can't draw for STVT graph, means you can draw. So, because this is not velocity time, so you can't draw. Leave it, children. So, what I will do instead, see, children, try to understand. 0 to 2 seconds, it traveled 20 meters. Okay, and next to 4 seconds, next to 4 seconds in 6 seconds. In 6 seconds, it traveled 160 meters. In next to 4 seconds, it traveled 160 meters. Then, what will be the velocity after 7 seconds from the start? Means 7 seconds. In what will be its velocity? Here, what is the velocity? Here it is traveling 20 meters. Here it is traveling 20 meters. Okay, children. Let's children here we have initial velocity. Here we have initial velocity u, children. U is 0. U is 0 and s is 20 meters and time is given. Let's find acceleration, children. What is the formula we will use? S is equal to
UT plus half
ut plus r square. Help me, children. 20 into 0 into 2.
into 2 plus 1 by 2 into a into 2
2
square.
square. Very good. So 20 is equal
20 is
to
equal to 2
a
to Acceleration.
So A is equal to 10 meter per second square is the acceleration. Acceleration. Will the same acceleration is it there here also we will see each other. But the same acceleration is it there here also we will see each other. Okay. Now, but what is the final velocity here? We know A is equal to V minus U by T. Please check that. A is equal to V minus U by T. Okay. So acceleration is 10. V we don't know. U is how much? U is 0.
0.
Okay. By time in 2 seconds.
2 seconds.
In 2 seconds, how much? So here his speed will be 20 meters per second. His speed will be 20 meters per second. Now, children, let's check acceleration here also. Is it 10 or not? If it is 10, then we can find answer. Let's check. Let's check. Is it correct 10 or not? Okay. For this part of the motion, you have to listen carefully. Initial, final velocity will become initial velocity. For this part of the motion, its final velocity will become its initial velocity. Please try to understand, children. S is equal to ut plus half at square. How much he traveled? 160. U initially how much? 20. Time how much? 2 to 6 means 4 plus
4.
half into a into 4 square. Let's check.
Sir, U is 2, sir.
U is 2. How na? 20. 20.
Okay.
It's this part of the final motion. This part final velocity will become this part initial velocity. For this part final velocity will become this part initial velocity. Malika, okay na?
Okay.
160 is equal to 80 plus 16a by 2. This goes here. 80 is equal to 80. A is equal to, again you got 10. So here also 10, here also 10. So here also it will be 10. Why did you do again, sir? You already got means I want to check whether acceleration is constant or not. If acceleration is not constant, we can't find final velocity. Finally, A is equal to V minus U by T. A is equal to V minus U by T. What is acceleration we got, children? 10. He is asking final velocity here. Initial velocity how much? 0. In how many seconds you want? 7 seconds.
7.
So 70 meters per second is the final velocity. I know you people did not understand anything, even one point also you did not understand. Those who didn't understand, just then I will give the explanation. Please see here, children. Please don't sit like that, children. See, 0 to 2 seconds, it traveled 20 meters. 2 to 6 seconds, it traveled 160 meters. 6 to 7 seconds, here what is the final velocity? They asked. What I did means, first I found out acceleration. I got 10. After getting acceleration, I checked here also is it 10 or not. Why did you check, sir? Means I want to see whether acceleration is constant or not. If acceleration is keep on changing, you can't find out. Acceleration from here to here 10. Here also I got 10. Here also I got 10. How I found out acceleration? First, using this, I found out V here. The V here will become U here. The final velocity for this part of the motion will become initial velocity for this part of the motion. And I checked there, I got acceleration in both the cases 10 only. Once I got acceleration in both the cases 10, then I used that acceleration only to find out final velocity. A is equal to V minus U by T. That is acceleration. Rate of change of velocity. What is acceleration? Rate of change of velocity. What is acceleration? Rate of change of velocity. What is acceleration? Varsha, can you define? Varsha, can you define acceleration?
Rate of change of velocity.
Rate, R-A-T-E, rate of change of velocity. Acceleration is what, Varsha?
Rate of change of velocity.
Rate of change of velocity. Rate is by time. Rate of change of velocity is acceleration. Rate of change of velocity is called acceleration. Next question, children. So, next, fifth question and children. That's sixth, fifth. An electron moving with a velocity of children. Electron is moving with a velocity of 5 into 10 to the power of 4 meter per second. Enters into a uniform electric field. Enters into a uniform electric field. Okay, and acquires a uniform acceleration of 10 to the power of 4 meters per second square. in the direction of initial motion. Calculate the time which electron would acquire velocity, double of its initial velocity. Double of its initial velocity means 10 into 10 to the power of 4. In which time it will happen? In which time it will happen? Srini,
Yes, sir.
initial velocity is there, final velocity is there, acceleration is there. I want time. Can we find?
V
A is equal to, what is the formula for acceleration? Rate
V
of
minus U by T.
change in
Rate of change in
velocity. Define acceleration again.
rate of change of velocity.
Define acceleration again.
Rate of change of velocity.
Now you have acceleration, you have V, you have U. Can't you find out T now?
Yes, sir. A
Correct.
is equals to 10 to the power of 4 is equals to 10 into 10 to the power of 4 into 10 to the power of 4 T there. Okay. 10 to the power of 4 common will take means 10 minus 5. T is equals to 5.
In 5 seconds, its velocity will become double. In 5 seconds, its velocity will become double.
Double.
In 5 seconds, its velocity will become double. Next question. An electron moving with a speed acquires a uniform and how much distance? How much distance would cover in this time? Same question, children. It is doubling the velocity. It is doubling the velocity in the uniform and acquires uniform acceleration. Acceleration is also same, but now he wants distance. Using this, I want distance. Saisha, can you tell? Using this, can we have to find out distance? Using this, we have to find distance. Saisha, can you tell?
Yes, sir.
What is the
Yes.
formula we will use?
V is equals to U.
Distance.
S is equals to UT.
V
V
is there, U is there, A is there, S is there.
V square minus U square is equals to 2AS.
Okay, in example, we will tell Nana 10 into
10
10 to the
into
power
10
of
to the
4
power 4 minus 5 into 10 to the power 2 is equals to 2 into 10 to the power 4 into S.
10 square is 100.
100 into 10 to the power 8. 25 into 10 to the power 8 is equals to 2 into 10 to the power 4 into S.
10 to the power of
S
8
is
you take
equals
common.
to 10 to the power 8 into 100 minus 25 by 2 into 10 to the power 4. 4 cancel. Okay. 2 in 10 to the power 4 is equals to 75 by 2. S is equals to 37.5 into 10 to the power 4 meters.
It travels. It travels. It is this acceleration. Next question. Okay, hope you are able to understand. Very, very easy questions I give. Next step. Children, two stones are thrown vertically upwards. Two stones are thrown vertically upwards simultaneously with their initial velocities u1 and u2. This initial velocity u1 and this initial velocity u2. Prove that the heights reached by them would be in the ratio of u1 square is to u2 square. Assume upward. What is the ratio of their heights? What is the ratio of their heights? What is the ratio of their heights? Simple sum.
H1 by H2 is equal to
H1 by H2 is equal to
U1 square by G
2G
by 2G by U2 square by 2G. 2G,
for
2G.
this. Why I am not writing G1 and G2? Why I am not writing G1?
Acceleration due to gravity is equal in both cases.
Is constant on a particular place. In a particular place, acceleration due to gravity is constant.
Constant.
2G,
2G, 2G cancel. H1 by H2 is equal to U1 square by U2 square.
That's square. So the ratio of their height is u1 square by u2 square. The ratio of the heights attained by the body h1 is to h2 is equal to u1 square by u2 square, because at a particular place acceleration due to gravity remains same. If you are taking this is one planet, this is one planet, this is one planet, g will change. I accept it. But on a particular place, g will remain same. This is Earth, this is Earth, this is Mars. Okay, then we can use. Okay, children. So what is the ratio? U1 square by U2 square are the ratios of the heights attained by both the bodies. U1 square by U2 square are the ratio of the heights attained by both the bodies. Okay, in a particular place. Yes. Okay. So next question. We'll do next question. 1 second. 1 second. Yeah, it's 1 second, children. I'll start. Sure. So I'm studying the motion only 1 second. I will give the book. Okay, children, we will stop here, children. Because book is not there, I will discuss motion.